Welcome back to our mathematics class. In today's class, we are continuing with coordinate geometry. We shall be looking specifically the section formula. Our topic is section formula. The first point we are going to look at here is the midpoint. The midpoint of the line segment joining S1, Y1 and S2, Y2 has coordinates S1 plus S2 all over 2 and Y1 plus Y2 all over 2. What we are saying in essence here is that if you have a line segment A and B, the midpoint of this line segment, we have the coordinates of this one as S1, Y1. We have for this one is S2, Y2. Now to find the midpoint here, let's call it M, midpoint. All you need to do is to add the S coordinate, so S1 plus S2 divided by 2, and add the Y coordinate, Y1 plus Y2 also divided by 2. The value you have is the coordinate of the point M, which is the midpoint of A and B. The second one, B. The point which divides the line segment S1, Y1 and S2, Y2 in the ratio M to N has coordinates MS2 plus NS1 all over M plus N, comma, MY2 plus NY1 all over M plus N. This is specifically used for eternal division of a line in the ratio M to N. So our D, 2 times 5 is 10, plus 3 times 2, which is 6, 16 divided by 2 is 8, and then we have 6 plus 12 is 18 divided by 2, which is 9. So this is the point of that line that is divided in the ratio 2 to 3. Let's take for the line segment AB, where our A is S1, Y1, and our B is S2, Y2. And this line is divided in the ratio M to N. And we want to find the point of the division. Call it D. And our D here is S, Y. Our interest now is to find the value of S and Y if the line AB is divided eternally in the ratio M to N. So in this regard, we find that our D will be equal to your M S2 plus your N S1 divided by M plus N, comma, then your M Y2 plus your N Y1 divided by M plus N. We now close the bracket. Now if we take our point A to be 2, 3, and then our point B to be maybe 5 and 3, we are now required to find the point of the division if the line is divided in the ratio, let's say 2 to 3. Now in this regard, you will now find your solution will now become your D is equal to, this is ratio M to N. So your 2 is M, your 3 is N. That is what it stands for now. So our D becomes our M, which is 2, times S2, and our S2 is 5, and then plus N, which is 3, and then times our S1, and our S1 in this place is 2. Everything will be divided by the ratio, sum of the ratio, which is 2 plus 3, comma, then your M again, which is 2, into your Y2 in this place is 3, and then plus n, which is 3, into your y1, which is 3. Everything again all over 2 plus 3. You close the bracket. When you simplify this, you will have here 10 plus 6, 16, 16 over 5. So this is 16 all over 5. And then you have 6 plus 9, which is 15 all over 5, and that is 3. So the point of the division in that ratio is the point 16.5, 3 as the solution to this problem for eternal division of a line in the ratio 2 to 3. For external division of a line in the ratio m to n, we will use the formula d, that is the point, will be equal to ms2 minus ns1 all over m minus n, and my2 minus ny1 all over m minus n. So that, for example, if you have a line, and let's call it the line PQ, and then this line is divided externally. Let's put it this way, our Q is here, and let's say we have another point here, T. So there's an external division from here to here, and then from here to here. So this is our D now, not the point of external division. So 1 is M to N. In this case, you simply will write, assuming our point P is equal to 3, let's say minus 3 and 4, and our point Q is equal to 2 and 6, then we can find, and the ratio M to N is equal to maybe 2 and minus 3, the ratio 2 to minus 3. Then the point D will be defined by, open bracket, our M, which is 2, multiplying our S2, which is 2, and then plus, this time it will be minus because it's external, minus N, which is minus 3, into our S1, and our S1 there is again minus 3. Everything here will be divided by 2 minus 3, and then we have 2 again into Y2, and our Y2 is 6 minus N, which is minus 3, and that will also go into your Y1, which is 4. Everything here will be divided by your 2 minus 3. You close the bracket. So eventually you have 4 minus 9. 4 minus 9 will give you minus 5 all over 1, all over minus 1, comma, and then 12 plus 12, which is 24 all over minus 1, and the final result becomes 5, minus 24, and this is the point of the division of the line PQ in the ratio M to N, external division. Our solved examples. Let's take the first example 1. What are the coordinates of the midpoint of the line joining the points 3, minus 5 and minus 1, 3? Solution. Remember, we are talking about midpoint. So let the midpoint be, X. So we have our S will be equal to S1 plus S2 over 2, Y1 plus Y2 over 2, because we're talking about midpoint. Whereas our S1? Our S1 is 3, and our S2 is minus 1 all over 2. Whereas our Y1 is minus 5, and our Y2 is 3 also over 2. Now simplify this, that is 2 all over 2, and this is minus 2 all over 2. Simplifying further, the point S will be equal to 1 minus 1. And this is the solution of the problem. Example number 2. What is the midpoint of the line joining the points 2x, y and s, 2y? Solution. Let the midpoint be n. Let the midpoint be n. So our m will be equal to s1 plus s2 all over 2, y1 plus y2 all over 2. Now, your s1 is 2s, and your s2 is s all over 2, and your y1 is y, and your y2 is 2y all over 2. Now, adding them, 3s all over 2 and 3y all over 2. And that gives you the midpoint. Example number 3. If M is a point 4, Q is the midpoint of the line joining L, P, minus 2 and N, Q, P, find the value of P and Q respectively. Our solution, remember the midpoint theorem, and here we have that our S1 plus S2 all over 2 is equal to 4. Therefore, S1 plus S2 is equal to 8, cross multiplication. And here, our S1 actually is P, and our S2 is Q, and that is equal to 8. Call this your first equation. Similarly, you have Y1 plus Y2 all over 2 is equal to Q. In other words, our minus 2 plus P is equal to 2Q. And of course, it means that P minus 2Q is equal to 2. This is your second equation. And you are going to solve equation 1 and 2 simultaneously. So subtract the equations. So we have equation 1 minus equation 2. P minus P is 0. Q minus 2P will give you 3Q. And then 8 minus 2 will give you 6. Therefore, your Q is equal to 2. Then you can now substitute your Q. Substitute Q equal to 2 in any of the equations. Let's say equation 1. When you do that, you will now have your P to be equal to 8 minus Q, and that is minus 2, and the value is 6. And because we are told to find the value of P and Q respectively, so our answer will be equal to P is equal to 6 and Q is equal to 2. And that is the solution to the problem. Example number 4. The midpoint of point P, 5, minus 2, and Q, S, Y is 4, minus 1. Find the coordinates of point Q. Solution. You will recall in this case that this is the midpoint, and the first value here 4 is associated with the S coordinate, or S coordinate, yes, while the minus 1 is associated with the Y. So in our solution, we simply find the midpoint of P and Q, and the midpoint of P and Q is 5 plus S all over 2, and this will be equal to 4. So that your S plus 5 is actually equal to 8, and your S is equal to 8 minus 5, and the value there is 3. Now similarly, you have Similarly, you now have for y, and the value of y there is minus 2 plus y is equal to minus 1. Now the result of this is that y is equal to minus 1 plus 2, and that is equal to 1. So the coordinates of the point Q therefore will be written as 3 and 1. Example number 5. The midpoint of the segment of the line y equal to 4s plus 3, which lies between the s-axis and y-axis, is dash. Now our solution, we have the coordinate axis, s and y axis. This is the line of y equal to 4s plus 3. Now, we have to look for any 2 points on this line. And we can do that by taking the point s equal to 0. This will give us the point y equal to 4, substituting the value of 0 in s plus 3, and eventually you have 3, because 4 times 0 is 0. Therefore, the point 0 and 3 is on the line, as indicated by the dot. Then we also take another point. When y is equal to 0, 4s plus 3 will be equal to 0. Therefore, s is equal to minus 3 over 4. In other words, minus 3 over 4 and 0 is another point on the line, as also indicated on the graph. Now, with these 2 points, we are required to find the midpoint between here and here. Therefore, our midpoint will be equal to, remember the midpoint theorem, minus 3 over 4 plus 0 divided by 2, command, and then we have 0 plus 3 divided by 2. Now simplifying this one, you have a minus 3 all over 8, and we have 3 all over 2. And this gives you the midpoint of the line between when s equal to 0 and when y is equal to 0.